excuse me, one of the things we'll start to figure out as we start going through zeros here is that sometimes we'll have real zeros and sometimes we'll have imaginary zeros. And that's okay. All right? That's going to be just fine. It's up to us to just factor things like we would normally do it. We're still going to factor them along the same lines as we did yesterday. We're still talking about higher degree polynomials. We're still going to use the same tips and tricks and things that we've been looking at. We just have them now with that one next step. What are the zeros? Remember, your zeros come from your terms, your factored terms. Your zeros are where it crosses the x-axis, things like that, all right? Little simple things we've always been working through with quadratics. So in this case here, remember, when you see three terms, remember what I call a term, each monomial within the sequence? When you see three terms, I want you to try and see if you can factor it like you would a regular quadratic. But you always want to check, do your degrees go down by half and then no more exponent, or no more variable, I should say. Is that the case here?
Yes.
Yeah. Fourth squared constant. Okay. Now, in this case, you're basically asking yourself, what times what is negative 12 that you add together to get negative 1? What is it? Negative 4 and positive 3. So, remember the trick the trick that we had when we had the fourth then the squared, to have two things to multiply together that gets x to the fourth, but they add together to be x squared, that means their variables are x squared. Okay? Because what's x squared times x squared? That's where it goes. Now, you just said it was minus 4 and then plus 3. Now remember, if you are FOILing that out, and you obviously don't have to do this all the time. When you FOIL this, you have x to the fourth plus 3x squared minus 4x squared minus 12. And these here become minus x squared. That's where this comes from. Yes, ma'am? We'll have to do a different method. Okay. We'll have to do it, and we haven't learned that yet. We'll get to that next week, because then next week we start fishing. 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 I did too. I lost a lure the other day. I said that in this class. I was so bummed. We had a nice pond right in front of our house, and I was out there fishing while I was grilling. I had time to kill, and nobody else wanted to go fishing. So I just used a little yellow spinnerbait, and I caught I had a fish on the line. It was pretty big. And I was bringing it in. It wound up being a big catfish. And I'm not lying. It was at least like this. And I get it to the very edge. As I bent down too soon with not enough slack in my line to pick him up. And he snapped back and snapped and took my lure. So bummed. It was a great lure. Very upset. But it's the story of my life. At least I have lures. So I bought a new lure yesterday, but now it's snowing. So I don't know how much fish I'll have to do.
Ice fishing.
Well, it's not much ice yet because I don't want to fall through it because I'm, not like 2 pounds. Anyway, we'll get to that stuff, and that goes along with it. Anyway, so back to here. Oops. Now, these two are your terms. Just like when we had quadratics, when we had terms, we set our terms equal to 0, and we solved them. We do the same thing here. X squared minus 4 is 0. X squared plus 3 is 0. Now, one of these is rather easy to solve for. So, this one, it's a difference of squares, isn't it? I could factor that further if I want, but since this is an equals 0 problem, why not just solve for x? I add the 4 over, and then what do? Square root. But what happens when you take a square root over an equals? Plus or minus. I'm still seeing people forget that. And then when you take a square root, this is another weird thing I see every once in a while still. Obviously, we have to take the square root here and here. When you take the square root, do you rewrite the square root? The only thing I have to rewrite the square root is if that was the square root of 8 and it was 2 root of 2. The square root of 4 is 2. You've done rooted it. Yes? That makes sense. All right. The other side, the same basic principle. Can I factor that? I can't, but I can still solve for it, can't I?
Yeah.
In this case here, I have x squared equals -3. You still have to take the square root, right? But what's the square root of -3? Good, equals plus or minus I root 3. So these become the zeros of that quadratic, excuse me, of that polynomial. In that polynomial, though, how many of those zeros are you able to graph via intercepts? Just the real ones, the plus or minus 2's. The plus or minus I root 3 is going to happen somewhere else. We just don't know where. Okay? So in this case here, if you start thinking about this, we'll get to the graphing of this tomorrow. I know that at plus and minus 2, those two touch there. What's the other one that you know happens? The -12. What's the -12? Your y-intercept. Okay. So I know somewhere along the lines, it's got to come through here, it's got to go through here, it's got to go through here. I don't know if it's going this way. I don't know if it's coming up this way. I don't know what it's doing yet. But when we learn a little bit of it tomorrow with what happens with the what's called end behavior, what's happening at the ends of the graph, we can figure out that piece really easily. And then we start to figure out the inside pieces by using another method. So there's little bits and tricks as we go through this as we'll start to be able to plot this. Okay? But that's how you solve a polynomial. You're still factoring like you would normally. It isn't anything different. Okay? Try this one. So sorry, it's a little blurry there. This is, I'll rewrite it. It's x to the 8th minus 3x to the 7th equals x to the 6th minus 3x to the 5th. And a partridge in the pear tree. It's a great song today. Okay. Since there's an equals here, what do you have to set one side to? 0. Now, are you going to move the x to the 8th, -3x to the 7th to the right, or are you going to move the x to the 6th and the -3x to the 5th to the left? Go to the left. Keep whatever the highest degree is, you want that to be positive. Always. Okay? Keep your highest degree positive to move everything towards it. So you have x to the 8th minus 3x to the 7th minus x to the 6th plus 3x to the 5th is 0. What was the trick yesterday we talked about when you have 4 terms? Yeah, group them. Okay? Group them. Also, when you have this style of polynomial, higher degree ones, try to put them in descending order. Okay? It naturally kind of makes it descending order, but it'll be easier to group when you have that into descending order. Bless you. Does that make sense? The descending order, remember what I meant by that? The degrees just go down in order. So if I group these two here, what's the GCF of x to the 8th minus 3x to the 7th? X to the 7th. So I factor out the x to the 7th. I'm left with x minus 3. Okay? The next term, I have minus in the third part, so I put a minus plus. Now what do they have in common? X to the 5th, good. So I take out the minus x to the 5th, and now I have x minus 3. So far, so good? Okay. Are the two things in the parentheses the same?
Yes.
That's very good. So we have x minus 3 and x to the 7th minus x to the 5th. Okay. Can I go further on that one? Yes. What do those two have in common? Those here have an x to the 5th in common. So this x minus 3 gets rewritten. See what happens? Because now what can you do with that one? It's a difference of squares. Okay? You cannot eliminate zeros by dividing out. That is not algebraically plausible. Okay? You can't do it. You can't map that. That's not mathable. We'll use that term, mapping. All right? So now, when I rewrite this, is everybody okay? Everybody's okay that's a difference of squares? Yeah. So if I go x to the 5th, x minus 3, x minus 1, x plus 1 is 0. Yeah. Okay? Each one of those values is its own term. Okay? We set terms equal to 0. All right? So this one, x plus 1 is 0, x minus 1 is 0, x minus 3 is 0, x to the 5th is 0. What does x to the 5th represent? Okay, so a number that multiplied by itself 5 times equals 0, wouldn't that just be Isn't that what you were saying? That's exactly what you're saying. And she's right. When you have something whenever you have something raised to any power, a variable to a power, that's the number of times that it equals 0 in this case. So that means whenever you have things that repeat zeros, I think we talked about this term before. Oops. If I do x squared plus 6x plus 9, if I factor that, what do you get? X plus 3. X plus 3. Where are your zeros for that? Negative 3. So it's when x equals negative 3, and it's twice, right? Now that means on a graph, it touched it at one spot, didn't it? In this case, it moved up because it was up like a cup. Remember what we called that when it was a repeated 0? No? It did. Very good. Multiplicity. Okay, I said that. I didn't hear you. I'm sorry. I said it unrealistic. Okay. No. That's cool. They're like, hey, guys, you really didn't say it, so I'm bringing it up. No. Multiplicity. Multiplicity is a repeated 0. Okay? You can have multiplicity in that case. The multiplicity of this 0 is 2, because it's there twice. The multiplicity of this 0 is 5, because it's there 5 times. Okay? So what we would say is that for finding our zeros in this case, for a polynomial like this, weird. We have a 0 at negative 1, 1, 3, and 0 with multiplicity of 5. That's your answer. Anytime that you have a repeated 0, I want you to state that it has multiplicity of however many times that 0 exists.
What if it's just a 0?
No, because then it just exists in one spot. Anytime it's more than 1. Okay? Anytime you have multiple zeros at the same location. Does that make more sense? Yeah. Anytime you have multiple zeros at the same location, I want you guys to get in the habit of saying that you have multiplicity at that value for however many times it is. Okay? I'm trying to bring in a little bit of the later half of this chapter in this because it works well. Okay? Not bad? Don't worry. Alright, try another one. Can you see that one okay? Yeah. Alright. Set it equal to 0. Set it equal to 0. Set it equal to 0. Start doing your GCF stuff. Start breaking it down and see what you come up with. Excuse me. Just do GCF. Well, just remember GCF. What's the greatest common factor? Well, there's more than one. So what's the greatest common factor? What's the most greatest common? X to the 4. Oh, yeah. Yes, sir. Good. And you're treating it just like you would if you squared. You know, x squared and x. You got 1x, you only have 1 left. None of the other factors. Yeah. It's not any different than what we have done in the past, it's just bigger numbers. No problem. It's last Thursday we had a half day. I told you should have taken a bet on that one. Did you? I should have. Now here so they're going to go. Teachers, please disregard that bell. Because they always forget on half days the week before. They forget to reset it for the next Thursday. Because last week, we had conferences on Friday, so really nobody was really in the office at all. They'd go, oh, we should probably do that. So I tell you, I think it's funny. Did you at least get that far? Yes. Wait.
You know, I want to finish it soon.
Okay. What's that? It doesn't have to be 0, so it could be 2. Like in this case here, this one had multiplicity of 2 at -3. Yeah, if it's double. So I should have said this has with multiplicity of 2. Since there's 2 of them at -3, I would have said with multiplicity of 2. Is that what you're asking? So hopefully you're up to about here-ish. Okay. So x to the 4th minus 8x, x plus 3. Okay. Now, in this case now, that first term, or however you wrote it, there's another GCF. So here you take out the x, and you have an x cubed minus 8, and then x plus 3. So at this point, I know that this is a difference of cubes. So I can factor that one further. So what I'll do is I'm going to write out, I have my x, I have my x plus 3. I'm going to put those two first. Remember, the order in which I write these things out makes no difference at all. For the, I'm just putting these two first, and then now my next one would be x minus x minus 2 because I do that. Yes, ma'am. Just like when we had problems like, what was it? 4x squared minus 2x. You took out a 2x, and you had 2x minus 1. Instead of making it 0, this equals 0, this equals 0. Same process. Same thing, okay? So here I've got, start breaking this down, x minus 2. Then you have x squared plus 2x plus 4. So you got that one? Okay. Now the tricky part. 3 of the zeros are easy to find. 3 of the zeros are going to be easy to find. It's at 0, -3, and +2. Whenever you're doing sums or differences of cubes, the trinomial you get will not be factorable. Okay? The trinomial you get will not be factorable. Use quadratic formula. It's usually quicker. Okay? Yes, ma'am? There's a whole pattern in the notes that we did yesterday that has that. All right? So here, you want to jump to get your zeros by the opposite of b plus or minus square root b squared minus 4ac all over 2a. So when you do this part here, excuse me, I get -2 plus or minus 4 minus 4 times 1 times 4 all over 2. What's 4 times 4? 16. 4 minus 16 is how much? -12. So I have -2 plus or minus the square root of -12. Oops. All over 2. What's the square root of -12? Very good, very good, very good. 2i root 3. So now I'm at -2 plus or minus 2i root 3 all over 2.
-1.
Very good, very good. I want to make sure you saw the -1. When you simplify this out, notice all 3 of the main coefficients are even. In fact, they're all 2's. But when you simplify the 2 and the -2, you wind up with -1 plus or minus I root 3. And that compensates for the zeros here. So the tricky part here is going to be when you get the imaginary zeros, when you have sums or differences of cubes. Okay? When you do that, you'll always have one real and you'll have 2 imaginary. Yes, ma'am?
Isn't that actually big, right?
Yes. Remember I asked you on the test, draw a graph of imaginary zeros. Because what happened? Where was it? Above or below the x-axis? It still changes, doesn't it? Same idea. Okay. What was the degree of this one? It was 5th degree polynomial, wasn't it? How many zeros did we just find?
4.
3.
4. 4. 4.
4. It's 4. It's 5. Wait, why did you have the plus or minus?
1 little, 2 little, 3 little zeros, 4 little, 5 little total zeros.
Wait, what?
Where did you find?
Plus or minus.
Plus or minus.
Okay, why is that 0?
It said equal to 0. Just like here. When you had this, you said equal to 0. There's 2 terms. You set them equal to 0. So it's 0, 1/2.
Oh, so that's the term by itself.
Yes, sir. Yep. It's a term by itself. Okay? So yes, there are 5 zeros. Plus or minus counts for 2.
That's stupid.
You're stupid.
Logic confuses me, confuses me, everything confuses me.
Yeah. That's good, Sarah. All right, go this one. That's not a point. That's not a point. It's just 3. 3x to the 7. Get your zeros. Please and thank you. What? Oh, what was you? Oh, what was you? I know. This gets complicated. This gets complicated really quick. I'm trying to break it into smaller chunks.
Is that a negative?
It is, I just said that's not, it's just a dot that showed up. I tried to cross it off so you can't get it. Or no, 3 days. There, now you don't have to worry about it.
Very nice. Yeah.
Yeah, like,
Don't worry, you're not the first one. I did that like.
so I shouldn't like mutter under my breath, so I have to be thinking about people a lot of times. Or you want me to, like.
I probably want to thank you,
That's not what
Gotta work on your internet though. You get lost in it. Yo,
you want this song on YouTube, right?
yeah, or just send to me. Either one's fine.
You're gonna be really.
What's that? Yeah, it's just due by tomorrow morning. Hopefully we did this. Hopefully we did that. Now, after that, DCF. Okay. You got that far. Then, the 3x to the fourth, there's nothing you can do with it. It's 0 with multiplicity of what? 4. So this one, you know you have a 0 with multiplicity, multiplicity of 4. Here, we can do stuff. Cube root of x cubed. X cube root of 27? 3. So we have x minus 3. Now you have x squared plus 3x plus 9. So this 0 is 3. And then the other 0, we have to use quadratic formula for. Negative 3 plus or minus square root. 3 squared minus 4 AC. 4 times 9, 36. Subtract that from 9, you get negative 25. Is that right? Wait, no. 27, sorry. And this was all over, sorry, 2a, so it's 2. So we have negative 3 plus or minus the square root of negative 27 all over 2. Square root of negative 27 is what? Negative 3I root 3. Does that sound right? Yeah. So your other 0 would be at negative 3 plus or minus 3I root 3 all over 2. Now remember, this polynomial started out at what degree? 7th degree. You had a 0 with multiplicity of 4, so there's 4 of your zeros. You have a 0 here at 3, there's your 5th 0. This one has 2 more. 7th degree polynomial had how many zeros possible? What? You'll be, yeah, I know, it's gonna be super exciting. Super exciting. You can, I don't know what you're gonna see. You'll see, you'll know, in this case here, what's your y-intercept gonna be? 0. What's the only x-intercept you're gonna have besides 0? 3. The rest of it, we don't know what we're doing yet. Alright? So, let's do the same section. And let's see, do some zeros. And which column here works out best. Let's do this. Let's do this column here. All right. Find zeros. Find zeros. Find zeros. I know the instructions say real number. I want you guys to find the zeros. Yeah, find all zeros. Okay. What is that? 6 of them. So it should be. So it's just that it's that same page. It's just that one little column there. Go through there. Find your zeros off of those. The top tip. I look at 83. What are you gonna do? No. Set equals 0. Which way are you gonna? What are you gonna move? The negative 2x to the 6th. That's the time I'm going to move that one to make it positive. All right. Move this one to the right, and you get 2x to the 6th plus 16. Do that. Okay. Do that. That's kind of the trick. Okay. All right. Yeah. Oh, we did. Did you try? No, but